Here's 20.2. It is on pyramids and cones. So things that you need to know about pyramids and cones. First of all, it's very, very similar in formula, but you have to know kind of the idea behind a pyramid and a cone. Spoiler alert, this is discussion 20 topics. So it says, what are the similarities and differences between cones and pyramids? So first of all, cones and pyramids all come up to an apex. On a pyramid, it's called an apex. I believe on a cone, they call it the vertex, but it's either way. Yeah, it's also an apex. So they all come up to an apex. The formula itself, it always looks like this, whether it's a cone or a pyramid. So there's 1/3 area of the base times the height. The only thing that's different, so the things that are the same, 1/3 is always there, the height of the thing is there, and the area of the base is always there. The thing that's different is the shape of the base. So a pyramid and a cone are very similar, just the base is different. So a pyramid, the base would be some sort of polygon, and for a cone, it's a circle. And that's basically what you have to do. They talk about this long thing to explain it all, and we want to go into the problems. So this first problem says, for me anyway, it says the base of a rectangular pyramid is 7 centimeters long, 3 centimeters wide. And if the pyramid has a height of 5 centimeters, what is its volume? So I drew out the pyramid. You don't have to do that every time. I like to do it because I visualize it better. But then you're just going to plug that into the formula. Let's figure out what that base is. Notice that these two things right here, this makes up the base. So I would just do 7 multiplied by 3. So here we go. Excuse my handwriting. So it's 1/3 multiplied by 7, multiplied by 3, multiplied by 5. Let me show you a nice, fast, easy way of looking at this one. I can see it's 1/3, which is the same thing as dividing by 3. And right here, I multiply by 3. So those are just like it cancels out. And then all I have to calculate is 7 multiplied by 5, which I know is 35. This one says the right cone and the right cylinder have the same base with the same area, the same height. What is the difference between them? So remember that the cone is 1/3 of the volume of the cylinder. In other words, the cylinder is 3 times the volume of the cone. So the cone can fill the cylinder exactly 3 times. That's the answer. So that was 20.2. Next question, I mean. And then this is some really hard-hitting math. Which one of these looks like a cone? Does a blueberry look like a cone? Does an Erlenmeyer flask look like a cone? Does this thing right here look like a cone? Or does that look like a cone? I'm going to go with the flask. It most closely resembles a cone. All right.